In this first question, you're told that the class interval has a frequency of 20 and its width 1.5 and height 12. So the area 12 times 1.5 is 18. 18 square centimetres represents 20 people. So 1 square centimetre divided by 18. But we've got the total area is 94.5. So 1 square centimetre represents 20 over 18. 94.5 represents 20 over 18 times 94.5. 105 people. In question 2, we can see that the midpoints are 7.5 and 25. They're the middle of the coded time column. And entering these numbers on your calculator, we get the mean is 10.3125 and the standard deviation 6.6188. Now, to work out the median, the mark scheme specifically allows you to have the 40.5th number or the 40th number. So I prefer the 40.5th, but it doesn't matter. So a little diagram like this helps. We know that the time goes from 5 to 10, and we need to find the median, which I'll call Q2. And the frequencies go from 20 to 44, but we're on the 40.5th number. So that gap divided by that gap is this gap divided by that gap. So 40.5 minus 20 divided by Q2 minus 5 is 44 minus 20 divided by 10 minus 5. Solve that equation and we get 9.2. But as I said, they do allow you to use the 40th number. It's the same principle, and so there's 9.2 or 9.17 is allowed. Just check there, that's actually 9.27. The 7 didn't get copied. So in question 3, we want the probability that t equals 2. How do you get a 2? It's 0 followed by 2, or it's 1 followed by 1, or it's 2 followed by 0. Each of these has probability 1/6 squared. 0 is 1/6, 2 is 1/6, and so on. So work that out is 1/12. In part B, we want the probability that t equals 3. How do you get a 3? We can get a 3 first up, so the probability of that is a half. Or you can do a 0 followed by a 3. 0 is a sixth, 3 is a half. Or 1 followed by 2, 6 squared, or 2 followed by 1, 6 squared. And so that works out to be 23 over 36. And in part C, a conditional probability. Given that the die is rolled twice, find the probability the score is 3. So what's the probability that the score is 3, given that it's rolled twice? And the formula for that is t equals 3 and rolled twice, divided by dice rolled twice. So that's the formula for a conditional probability. That and that happening, divided by just that happening. So t equals 3 and the dice rolled twice. That's these ones here, 0, 3, 1, 2, 2, 1, just those last 3 terms. And the probability the dice is rolled twice, well, it's a half, because a half you get a 3 first up, so a half you don't get a 3 first up. And that works out to be 5/18. Now in question 4, A and C are mutually exclusive, so the probability that you get A or C here is probability of A plus the probability of C. Normally it would be minus the probability of A and C, but that's 0. So that's simply 9/10. In part B, we need to show the probability of B, and the way to do that is to use these two formulas here. A and B is A times B, because they're independent, and A or B is A plus B minus A and B, because that's the general rule. So substituting those values in, A or B is 5/8, A is 2/5, that we don't know, and A and B is A times B, 2/5 times the probability of B. Then rearrange that equation and we get 3/8. Part C, another conditional probability. A, given that B's happened, that's A and B over B. A and B is this, B is that, which is 2/5. Although it is probably better to realise that A given B is A because they're independent. But either way you get 2/5. And then we have part D. So from here we can see that A and B is 2/5 times 3/8, which works out to be 3/20. So probability of A and not B is 2/5 minus 3/20. So 2/5 is A and B is 3/20, there it is. And so this bit here, which is A and not B, that's a quarter. So that's how we got 3/20, A and B is here. And then take away from 2/5, because that's the probability of A, that's a quarter. Now we're told that not C and not B is 3/10, so that means everything outside here is 3/10. So what's the gappy bit outside all three circles? Well, it's 3/10 minus that quarter, which makes that 1/20. So because everything outside B and C there is 3/10, then everything outside the whole lot is 3/10 minus a quarter to make 1/20. Now for the last bits I labelled this little area here P, this Q and this R. So B intersect not A, B and not A is 3/8 minus 3/20. And that's because we know that the probability of B is 3/8, so everything inside there is 3/8. We've just been told this bit is 3/20, so therefore we know that P plus Q is 3/8 minus 3/20, so that's 9/40. Now we're told the probability of C is a half, we were told that in the question, so that means that Q plus R must equal a half. And what about P plus Q plus R? Well, that's everything minus 1/20 minus 3/20 minus a quarter, so that's 11/20. So we end up with three equations which we can solve like this. P must be 11/20 minus Q plus R. P plus Q plus R is 11/20, so take away Q plus R, we get what P is. Once we know what P is, we work out what Q is. Once we know what they are, we can work out what R is. And then we end up with those bits there. In question 5, we can do SUVAT twice, for the first section and for the second section. And the key to this is realising that the final speed in the first section is the initial speed in the second section. So using the rarely used S equals Vt minus a half At squared, we can get an equation involving x and a, and then using S equals Ut plus half At squared, we can get another equation involving x and a, so therefore we can work out what x is, we can work out what a is. I'll just put that into the calculator. So we know what a is, and we were asked to work out what u was, so using V equals u plus At, we can now work out what u is, which is 12. Now for question 6, remember to draw a nice large clear diagram. Here it is. We've got force down here, we've got force up here. I've given the distances from the left hand end. If I take moments about A, then 0.6 times C, that's an anti-clockwise moment, and that equals these two moments which are clockwise. So it's 30g times 2, 50g times 4, so C works out to be 4250. I've put in there what I'm doing, I've taken moments about A. Now I've put in here that I'm going to resolve vertically. C must equal A plus 30g plus 50g, so I can work out what A is. Now in part B, I'm going to take moments about C. So it's 0.6 times 5,000, because we're told that the support will break if that's more than 5,000. So 0.6 times 5,000 is 1.4 times 30g plus 3.4 times mg, because this time we've got a new mass here. I suppose I was a bit lazy here. I should really draw another diagram showing 5,000 there and mg there. But using that, we've got 77.683. It says what's the integer value. Remember, at the end of every question, read the question. You may think you've answered it, but just read the question, check you've done it. It says the greatest integer mass that will be supported. 78 will break the support, 77 won't. And part C, the particle is the weight of the die that acts at a point. And now question 7, a nice large clear diagram. We've got the two particles, 4G and mg. We've got tension in the strings. It's in limiting equilibrium, and it says P is on the point of slipping down the plane, so friction must act this way. It's on the point of slipping down the plane, so friction acts that way. So now we've got all the forces, we can start to write out some equations. So F equals mu r. Rp, that's the reaction force at P, must equal 4G times cos alpha. And we can work out what cos alpha is. We know tan alpha is 3/4, so cos alpha is 4/5. So we can work out that Rp is 16G over 5, so F is 1/4 of that, that's 4G over 5. Let's resolve in this direction. T plus F equals 4G sine alpha. I know what sine alpha is, it's 3/5. So T plus F is 12G over 5, but I know what F is, so now I can work out what T is. Now let's resolve down this plane. There's no friction on this plane, it says it's smooth. So T must equal mg sine beta. Sine beta is 4/5, so T is 4mg over 5. So because T is 8g over 5, but it's also 4mg over 5, those two are equal, so m must equal 2. Now in part B, considering alpha and beta, if you work those out, then alpha plus beta adds up to 90. So there's a 90 degree there, so this angle here is also 90 degrees. And because these forces are equal, they're both the tension, then the resultant force must be in the middle of those, because they're equal. So it's 4mg over 5 times cos 45 plus 4mg over 5 times cos 45, works out to be 22.2 newtons. And the direction, we can work that out. Because we know this angle here is alpha, it's alpha there, so it's alpha there. Because that's alpha, then this angle here is 90 minus alpha. So it's 90 minus alpha plus 45 to the horizontal from the left, or which works out to be 98.1, or take away from 180, 81.9 to the horizontal from the right.